Welcome to Modeling Mastery, the podcast where we explore the art and science of software design. I'm Hex.
And I'm Byte. In our last two chapters, we've been deep in the world of tactical design, covering the foundational building blocks of our model: entities, which are defined by identity, and value objects, which describe and measure things.
We focused on the things in our domain. But what happens when we encounter a piece of domain logic that isn't a thing? It's a process, an action, a calculation that involves multiple objects and doesn't seem to have a natural home.
That's the central question of Chapter 7, Services. This chapter introduces the domain service, a pattern for modeling those stateless operations that are a crucial part of the domain. We'll be very careful to distinguish this from an application service or a microservice.
We will explore what a domain service is, the criteria for when to use one, and just as importantly, when to avoid the temptation. The goal is to understand how to model these essential domain operations without accidentally creating an anemic model.
It's a fine but important line to walk. Let's get into it.
Byte, we've spent a lot of time discussing how to model the things in our domain, the entities and value objects. But sometimes a piece of core business logic isn't a thing at all. It's a pure action or a process. When that operation doesn't feel like a natural responsibility of any single entity or value object, where does it go?
This is a classic modeling challenge. The knee-jerk reaction for many developers is to create some kind of manager or helper class and put the logic there. DDD provides a more formal and explicit pattern for this exact situation, the domain service.
And it's crucial that we start by clarifying what a domain service is, because the word service is probably one of the most overloaded terms in software development.
Absolutely. First and foremost, a domain service is not an application service. An application service lives in the application layer, outside the domain model. Its job is to coordinate a use case, handle transactions, and act as a client to the domain model by calling methods on our aggregates. A domain service, in contrast, lives inside the domain model and contains genuine domain-specific business logic.
The book defines a domain service very precisely. It is a stateless operation that fulfills a domain-specific task. You should create one when a significant business process or transformation doesn't seem to be a natural responsibility of any single entity or value object.
A great example is a calculation that requires input from multiple different aggregates. For instance, calculating a complex shipping cost might depend on the customer aggregate for their loyalty status, the order aggregate for the items and weight, and a warehouse aggregate for the origin location. Putting that calculation logic on any single one of those aggregates would feel unnatural and give it too many responsibilities. A shipping cost calculator domain service would be the perfect place for that logic.
But this pattern comes with a very important warning. A domain service can be easily overused. If we are not careful, we can start putting all our business logic into services, which is the fastest path back to an anemic domain model where our entities and value objects become nothing more than passive data bags.
It's the silver bullet temptation. The default should always be to place behavior directly on the objects that own the state, our entities and value objects. A domain service should be a conscious choice you make only after you've determined that the logic truly is a standalone, stateless operation that doesn't belong anywhere else. They should be relatively rare.
Let's make the concept of a domain service concrete with the calculation example from the SaaS Ovation case study. Initially, the product aggregate contained a collection of all its associated backlog item instances. This made it simple to have a method on the product itself called business priority totals that would calculate the total priority across all its items.
Right, that was a clean instance method because the product owned all the necessary data. But the team later made a correct and important design decision to refactor backlog item into its own separate aggregate. They did this to follow the rule of designing small aggregates. This was a great move for transactional integrity and performance, but it broke the business priority totals method. The product no longer had direct access to the collection of backlog items.
This left the team with a quandary. The calculation was still a piece of essential domain logic, but where did it belong now? Their first instinct was to change it to a static method on the product class. But that's a code smell. The calculation is no longer about the internal state of a single product instance. It's a higher-level process that coordinates between multiple aggregates.
This is the classic scenario that signals the need for a domain service. The logic doesn't fit on the product aggregate, and it certainly doesn't fit on a single backlog item. So the team modeled it as a new domain service called Business Priority Calculator. This is the perfect name because it's explicit, stateless, and comes directly from the ubiquitous language.
A domain service like this is free to use other domain-centric components, such as repositories, which is something an aggregate should almost never do. The implementation of the business priority totals method inside this new service is straightforward.
Exactly. It takes a product ID as input. Internally, it uses the backlog item repository to query for all outstanding backlog item aggregates associated with that product. Then it iterates through that collection, sums up the various ratings, benefit, cost, penalty, and risk from each backlog item's business priority value object. Finally, it uses those sums to create and return a new business priority totals value object with the final calculated result.
It's a pure, stateless domain operation, and it's important to be clear about the layers here. The client that invokes this business priority calculator is the application service. The application service remains a thin coordinator. It calls the domain service to perform the complex business calculation and then uses the resulting value object to fulfill the use case.
This is a much cleaner design. The business logic is now correctly encapsulated in a dedicated, testable service with a name that clearly communicates its purpose. It keeps the aggregates focused on their own invariants and demonstrates a perfect, justified use of a domain service for a calculation process that cuts across aggregates. Another important use case for a domain service is for transformations, especially when integrating between bounded contexts.
The business priority calculator we discussed in our last episode was modeled as a simple concrete class. This brings up a common and important design question that developers face. Should a domain service be defined by a separate interface, or is a single concrete class enough?
That's a great topic, because the answer really depends on the service's purpose. The book explains the separated interface pattern, which is a powerful choice for a few key reasons. First, if you anticipate having multiple swappable implementations of the same domain operation, different strategies for a calculation, for example, an interface is essential. Second, it's a key enabler of the dependency inversion principle. You can define the service interface in your domain model layer, but place the technical implementation in your infrastructure layer. This is common for services that need to integrate with external systems.
On the other hand, if a service contains pure, non-technical domain logic and you only ever expect to have one implementation, creating a separate interface can feel like unnecessary ceremony. A single concrete class named for the concept in the ubiquitous language, like the business priority calculator, can be a simpler and more direct solution.
And this is where we often see that common code smell the book alludes to, naming an implementation class my service impl. If your implementation doesn't have a more descriptive, specialized name, it's a strong signal that you probably didn't need a separate interface in the first place. The SaaS Ovation team actually debates this and decides to use a single concrete class for their authentication service initially because it doesn't have a technical implementation.
Let's use that authentication service as another great example of why a domain service is needed. The business requirement is clear. A user can be authenticated, but only if their owning tenant is active. This seemingly simple rule is tricky to place.
It really is. The team in the book struggles with this. If you put an authenticate method on the user entity, it has no way of knowing if the tenant is active. If you put the method on the tenant entity, you've now burdened the tenant with responsibilities it shouldn't have, like dealing with password encryption. And if you put all this coordination logic in the application service, you're leaking core domain rules out of the model and making the application service too fat.
None of those are good options. The correct place for this logic is in a dedicated, stateless domain service. The authentication service is the perfect solution because its single responsibility is to orchestrate this specific business process. Inside its authenticate method, it can use the tenant repository to find the tenant and check its status. It can use an encryption service to handle the password. And it can use the user repository to find the user with the matching credentials. It coordinates all the necessary domain objects to fulfill one cohesive business operation.
And it's important to look at what the service returns. It doesn't hand back the entire user aggregate, which would be a security risk and would expose a lot of internal state. Instead, it returns a simple, safe value object called a user descriptor. This object contains only the minimal, non-sensitive information the client needs to proceed, for example, to create a user session.
This example perfectly encapsulates the role of a domain service. It takes a significant business process that spans multiple domain objects, gives it an explicit name in the ubiquitous language, and provides a clean, stateless operation. This allows the application service to remain a thin coordinator and keeps the aggregates focused on protecting their own invariants. We've established what a domain service is and seen a couple of great examples. But like any part of the model, it's only as good as our ability to verify its correctness. Let's talk about how we test these services.
Because domain services are stateless, they're actually quite easy to test. The book provides an excellent example with the authentication service test. The key is that the tests are written from the perspective of the service's client, which is typically an application service. They demonstrate the expected use of the service according to the ubiquitous language.
The test suite is very methodical. First, it sets up the necessary state, for instance, by creating a fixture for a user and adding it to a test repository. Then it tests the happy path. It calls the authenticate method with the correct credentials and asserts that it receives a valid user descriptor value object in return, with all the correct details.
After proving the success case, the test suite then rigorously checks all the failure scenarios. It makes a call with a bogus tenant ID and asserts the result is null. It calls again with a wrong username and asserts the result is null. Finally, it calls with a bad password and again asserts the result is null. This proves that the service correctly handles every branch of the business logic. It's a clear behavioral specification for the service.
It's also important to note that because the service's dependencies, like its required repositories, are provided to it, we can easily use in-memory or mocked implementations during testing. This keeps the tests for our domain logic completely isolated from any infrastructure concerns, making them fast and reliable.
Now, before we wrap up, we need to address a final cautionary point from the chapter. The book mentions the idea of creating a mini layer of domain services that sit above the entities and value objects. This can be tempting in domains that seem to have a lot of stateless, cross-cutting operations.
But this is an incredibly dangerous path if not taken with extreme caution. This pattern is a slippery slope that can lead a team right back to where they started, with an anemic domain model. If developers start to see services as the default place for all business logic, they will systematically strip the behavior out of the entities and value objects, turning them back into the passive data bags we've been trying so hard to avoid.
It's a critical warning. The primary home for domain logic should always be on the objects that hold the state, the entities and value objects. A domain service is a specific tool for a specific problem, a significant stateless domain operation that truly has no other natural home. It should be the exception, not the rule.
An excellent summary. A domain service is an essential part of the DDD tactical toolkit, but it must be used with discipline and clear intent. And with that, we've covered the core concepts of this important pattern.